All right, let's go for it here. So chapter 3 is graphing. We're going to start off the example in the textbook. It's more of just trying to talk to you about what the whole concept of graphing. Why do we do it? Whenever there's a relationship between two different numbers, and the example the book does gives you the speed of a race car in terms of seconds and how many miles per hour it's going. So at 0, of course, it's going 0 because time hasn't started, right? At exactly 1 second, this race car is going 72.7 miles per hour. At exactly second 2, the second, now it's at almost 130 miles an hour. So whenever there's a relationship between two different things, two different sets of numbers, you got yourself a graph. And the reason for it is, look how many solutions there are. That's one solution, right? 0 gives you 0. There's another solution, and we have not even talked about half seconds, right? Can we also talk about what's happening at 1.5 seconds? We can, right? If we took a reading at exactly 1.5 seconds, right? So how many solutions are here? There's an infinite amount of solutions. We could do it at every 0.1 or 0.10th of a second. We could ever do it at every 100th of a second. You see how this thing expands. True, yes. So notice this is not, in chapter 3, most of the time we're going to be dealing with linear equations, which means the straight lines. Notice this is not sort of a straight line if you think about it here. So I'm going to give you guys like 3 different ways we sort of look at this. This guy is called a bar graph. This is most of the time you'll see this in statistics. If you guys are going to go on to after Math 63, if you guys go on to Math 25, you'll see these a lot, statistical drawings. Also, what you can do is you can just plot them as different, just individual points. This would be more called a scatter plot. A scatter plot is when you just have those individual points. That's all you have. They're not connected, no nothing. We're going to do more like this. We're going to start connecting points, except ours, look at this one. It's not a straight line though, huh? It sort of starts curving because eventually it's going to have to taper off, right? You can't be going faster and faster and faster forever. So yeah, in terms of a car, in reality, we call these curves. Usually in reality, we have lots of curves. But we're going to be doing very, very basic stuff. Okay, so just real quick here, just an illustration again. Let's talk about this. Let's talk about odd numbers. And again, don't need to write it down, just kind of think with me here. We'll get to writing down in just a bit. So if you're talking about odd numbers, the sequence of odd numbers starts with the 1, next odd number with 3, then 5, then 7, then 9, forever, right? So there's a difference between position and value. So the first odd number that we encounter, first positive odd number, I guess I should say, is 1. The second odd number is 3. Third odd number is 5. Everybody agreed with this, right? Fourth odd number is 7. The fifth odd number is 9. And so what we can do is we can actually make a scatter plot. We can make a little graph like this, right? Here's your odd numbers. Here's your position. Here are your odd numbers. So notice, what do you guys say? Is that a straight line? Yeah, if you were to connect them, that would be a straight line. Sometimes things are not straight lines, right? These are squares. So if you take 1, you square it, it becomes a 1. If you take 2, square it, it becomes 4. Take 3, square it, becomes a 9. So notice, it's just relationship between two numbers. That's all graphs are made out of. So is this a straight line? Nah, it looks like it's curving, huh? Okay, so just for practice, let's do a scatter plot. Then from here on out, we'll start connecting lines. But let's just, for practice sake, let's just do one time. Let's do a scatter plot. So can you construct a scatter diagram or scatter plot based upon the even numbers? All right, one thing we should know is the first even number is 0, because we consider 0 still an even number. So let me at least start it for you here. So the first even number we consider to be 0. The second even number is 2. And you guys continue. Let's go, you can continue forever, of course, but let's go out to 6 positions. That's what I want to do. Yeah. over here, because this is considered more scaling graphs. There's a 1 right here, right? But we just don't write it down. Don't have to, because you don't really have to write down all the numbers. Technically, you should just write down at least one number, because one number will give you a scale. So if this 10 over here was a 10, then you know that every single one of these here counts as a 1. If this was like maybe like a 50 over here, that means you know each of these would count as a 5. Cool. So it just needs to give you a scale. All right, so let's see if you guys agree here. The third position, next even number would be 4. The next one after that, awesome. Next one after that, and then finally like 10. We good? So went out 6 even numbers. Can we construct a scatter plot or scatter diagram with this? All right, so again, starting at the origin here, if we say 1, the first position is going to be a 0. The second position will get a value of 2. So notice we're correlating this horizontal row to this vertical row. So 3, right here between the 2 and the 4, it's going to go up to a 4. The 4 is going to go up to a 6. Perfect. The 5, which is between the 4 and the 6, is going to go up to 8. And then the 6 is going to go up to 10. And the only question I have is, without writing any more numbers, can you still continue the pattern? Yeah, you pretty much know the next dot is going to land right over here, right? So that's why graphs are very useful, because once you can see a pattern, like, cool, got it. The rest of it's going to go like this. And that's what we'll use diagrams for. All right, again, this is called a scatter plot. With a scatter plot, you don't connect anything. Just leave it as individual points. Okay, but now let's go on to what we're really going to do. This is more like an algebra graphs here. Let's talk about it first. Algebra graphs, according to your definition, is based upon an x-coordinate and a y-coordinate. And this little thing right here in your textbook here, anybody know what page number this is? Figure 6. I don't know. Make me look it up. I understand. Cool. Page 177. 177. Here's what our algebra graph looks like here. You got a horizontal row, which I think you guys already know, right? From a long time. X-axis. You got the vertical, which is the y-axis. Input, output, yes. And then you got where they meet is called the origin. They got these things called quadrants. Quadrants 1, quadrants 2, 3, and 4. They become very important once you get to trigonometry. So now we're sort of just setting the basis for it. All right, one thing with quadrants, we always use Roman numerals for them. So it's Roman numeral 1, Roman numeral 2, 3, and 4. So again, if you want to write it down, some of you guys are writing it down, some of you guys are looking at your textbook, go for it, whatever you like. Okay, I think everybody's done by now. Real quick here, I know you know this here, but just real quickly here. The way we graph ordered pairs, so whenever you give me A comma B, in this case a 5 comma 2, we always start off at the origin. We're going to learn a few tricks along the way here, but initially when we graph points here, start off at the origin. The first number tells you your horizontal movement, so if it's a positive you go to the right, negative you go to the left. Next number gives you the vertical movement, so go positive go up, negative go down. So we plot that point, put a little dot there, and then we write the coordinate. So we write in parentheses 5 comma 2. Okay, good there? Because the next one is all yours now. Can you graph for me these 3 ordered pairs? So 2 comma 3, negative 5 1, and negative 1 negative 3. All right, the question that comes up usually is, Mr. H, do we need graph paper for this chapter? I don't require graph paper, but will it help? Absolutely, it's going to help. So if you have some graph paper, or if you want to buy those, they call it quad rule, right? Which is you just have boxes as opposed to lines. If you want to do that, that's fine. If you are going to graph just on regular paper, just kind of make sure you place it correctly here. And again, if you know what you're doing and you can check with the back of the book and you understand your graph versus the back of the book and you see if it's right or wrong, that's kind of what I want. I'll try to make do with what you give me. On some of these, especially later on graphs, you want to have pretty good graphs though. So you want to be as sort of neat as possible in the graphs. Alright, so let's go for it here. So hopefully you did this already here. So again, 2 is starting off the origin. Again, going up 2 to the right, 3 up, puts a little dot right here, and then we write the coordinates. So 2, 3. I think most of you guys are done here, so let me just write it out. Negative 5, 1, starting at the origin, going to go left 5, up 1. So we have a graph right there, and again, negative 5, 1. Label the coordinate, so you know which one's which. And negative 1, negative 3, starting at the origin, left 1, down 3, so it should be a dot right here. So how about negative 1, negative 3? Cool. Again, don't connect them, just the individual points themselves will connect later on here. All right, give you a little more practice here. All yours for these. Give you a minute to try. All right, let me put up the answers here, those that are done. Okay, match them up with the ones you have just to make sure got them all correct. All right, I think everybody's done with those here. Didn't see many erasers, so that's a good thing. All right, one extra thing the homework mentions, but the practice problems don't. So let's actually try this here. Let's try, I'm just going to write it as homework 29 and 31. Just so you can reference it in case you need to here. And I'll do a few homework problems, especially if they're not really in the part of the practice problems here, and they give you something totally different in the homework. I'll start off the homework problems for you guys. Okay, since we're doing every other odd, right, one of these is going to be actually your homework, right? The other one's sort of to look at. So let me read the directions here. So we have it says graph the points 4, 3, and -4, -1. Draw a straight line that passes through both of them. And then it says, does the graph, for 29, it says, does the graph of 2, 2 lie on the line? For 31, it says, does the graph of 0, -2 lie on the line? So technically, we just want to see if 2, 2 is actually on the line and 0, -2 is on the line. So let's go for it. First of all, let's graph 4, 3. So up from the origin, we'll go to the right 4, up 3. -4, -1 would be -4 to the left, down 1. And it says draw a line through these points. So kind of careful here. Think back to high school geometry. Whenever you say draw a line, what you're really saying is extend the line past those points and put arrows at the end. Remember that, how lines in geometry extend both ways forever in each direction. Let's review a little bit of vocabulary here, geometry stuff. If you say draw a line segment, remember a line segment starts and ends at a certain spot, right? If you say draw a line, they go on forever. What's the one that starts at a certain spot but goes on forever, one direction only? Do you remember that? I think it's called a ray, is it? A ray starts at a certain point and it goes on forever, only one direction, only one arrow. Cool. Okay, so a line here. So now the question is, does the point 2, 2 lie on the line? Yeah, absolutely. So here's where I said you probably want to draw very good lines if you need to. Get some graph paper, because sometimes you're going to have to draw them somewhat accurately. And if you're pretty accurate with just line paper, that's fine too. Okay, so in this case, 29 is yes. 2, 2 is on the line. 0, -2, yes or no?
No.
No, it's actually all the way down here. That's not going to happen. That's a no. But let's dig just a little bit deeper here into this situation here. What we're saying is, by any points that are on this line over here, we're saying there are solutions to this line. That means they fit. If this was a car speed, this is a solution for the car speed, that's a solution for car speed, that's a solution for the speed of the car, speed of the car, speed of the car. Does that make sense? And it's not on the line. And again, how many solutions do we have?
A lot.
An infinite amount of solutions, right? Okay, I think we're getting there. Let's do a little bit of a contrast here. So the next slide, starting 3.2, don't need to write it down, just kind of think with me here for a little bit. And here's the way the book presents it, and it's pretty good here. It starts off right here. It says, if we solve the equation 3x minus 2 equals 10, the solution is x equals 4. So let's talk about it. Again, don't need to write it down. Just kind of think with me here for a little bit. Let's see if this is true. How should we solve this? Yeah, add 2 to both sides. Yeah, that works. You got 3x is equal to 12. What should we do next?
3 goes into 3, 3 goes into 12, 4, x equals 4.
Awesome. Okay. Do you see how an equation like this gave us just one single answer, just a 4? So if you think about graphing it, what it turns out to be a single point on the line. And if it's a single point on the line, we can actually label it as x equals 4. We good? The problem in chapter 3 comes in is what happens if you add an x and a y at the same time? What happens if our equation is 2x plus y equals 3? Notice there's an x and a y. Again, just trying to make you understand the whole concept of one single answer and multiple answers.
So I have them on either side of the equal sign.
Maybe. Let's talk about it here. The whole concept is just the solution here. So the question is, one pair of answers that works is 2, and let me just real quick here. It says one pair of answers or number that work is x equals 2, y equals -1. If I plug in a 2, -1, and again, what I have to do is I have to plug in the 2 for the x and the -1 for the y. My question is that a solution? Yeah, plug it in, find out. So we're going to plug in a 2 for the x, and we're going to put in a -1 for the y. So true or false? Yeah, 2 times 2 is 4. 4 plus a -1 gives you a 3, absolutely. Good there? Now, if it was a linear equation from chapter 2, that would be done, would be over with, right? The question happens is, can I get another solution here? And of course, because I did it for my brain, and I put in one that works here. 0, 3, does that work? Okay, how about this one? 1, 1, does that work? Take a look at it. Let's see. 2 times 1 plus 1, is that 3? That's 3, huh? 2 plus 1 is 3. That's cool. And we haven't even started talking about fractions. So notice I already have 3 solutions, right? If I plug in some fractions in here, how about 1/2, 2? Will that work? 2 times 1/2 plus 2. Let's see, half of 2 is 1. 1 plus 2 is... Oh man. If I were to ask you or tell you, list me all the solutions, how long will you be here?
A long time.
You will die here. We good? So we have to think about a different way we can actually show all the solutions. We good? Instead of just writing it down. Okay.
I had some problems that were trying to find this in my homework where it's like list all the numbers between this and after this. And like, you know that we're taking turns, so I wrote down just like 4 numbers and like I got that.
Got it, okay. Yeah, you can either write down, there's something called set notation you could do it with too, but usually in this case what we do is we make a graph. Because whatever numbers are on that line, that's the solution for all those. Cool? So we make a graph to show us an infinite amount of solutions at the same time. Okay, how do we do it? Well, first of all, we're going to just work on just plugging in stuff. 3.3 is when we actually work on graphing. For right now, we're just going to work on what do we plug in. And what we want to learn here is that whatever the first number is, that's always going to be the x. Whatever the second number is, we're always going to be the y value. So if you're trying to plug in 9 comma a blank, the 9, what is that 9 going to go in for? For the x or for the y? The x. So it should look like this, right? It's going to be 4 times the 9 plus 3y is equal to 24. So 3.2, we're just working on the whole concept of just plugging in values. In fact, your book starts out pretty slow compared to most algebra textbooks in talking about graphing here. Usually the first 3 sections of your textbook is just one section in another algebra book.
It's also our algebra book and talk about it in comparison to a bunch of others. I was wondering, have you just looked through a lot during your time as a teacher, or are you learning that's textbook for fun?
Textbook for fun.
Textbook for fun? Cool.
Thank you, son. All right, so 9 times 4 is 36. Subtract 36 from both sides. How about a 3y equals -12? Everybody good there? Divide by 3. Voila. Now, can you write for me the ordered pair that is a solution? Yeah, cool. 9 comma -4. That is my solution set. So 2 others here. So now you got the 0 on the as a second coordinate. So I got to figure out which one you're going to plug in for the 0. All right, plug it in the 0 now for the y value. So 0 goes in for the y value here, so that's a 0. 3 times, hey, I like plugging in zeros. Aren't those easy? Plug it in 0, this all goes away. So it's just 4x over here is equal to 24 divided by 4 gives you 6. I like plugging in zeros. And this time, again, 3 is the first coordinate. So that means the 3 has to go in for the x value. So plug it in that one, 4 times 3. 12 is good. Subtracting 12 from both sides here. That cancels, leaving us with 3y is equal to 12 divided by 3. 4, and again, can you write the ordered pair that makes the solution? And again, 3.2, just working on plugging in values and finding solutions. 3.3, that's when we're going to actually start graphing. Okay, so 3 comma 4. 3 is what I plugged in, 4 is what I got out. And notice right here, now I have 3 solutions, right? There's the 3 solutions to the same exact equation. Glad it didn't tell me to find all of them, because we wouldn't be able to do so. All right, just for practice here, all yours here for this one. Oh, go back on this one. It's all yours. Give you guys a minute here. 2x minus 3y equals 6. And again, 0. I love 0 plugins. Everything gets to be canceled right away. I can really do that. Okay, so honesty question here. Raise your hand if you read 3.1, 3.2 prior to coming to class today. Ooh, got some takers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. I like that. Almost double digits today. Almost. Okay, not talking to the 9 of you here, but how many wish you would have read ahead by now? Okay, 1. At least we got into double digits.
I've actually done work with graphs like this before, so I was looking at it when I was sitting here, like, oh, I actually have this.
Yeah, and graphs tend to be a lot different than solving equations. Some people enjoy both, some people just like one of them. So, okay, I'm going to do the first one here real quick here. So 2 gets plugged in, I'm sorry, 0 gets plugged in for the x over here, so 2 times 0 goes away, because it just becomes a 0. Divide through by -3, and voila, y equals -2. Again, ordered pair would be 0, -2. I'll let you guys finish up a little bit, give you guys a little time to finish up. All right, let me show you the other one here, just to make sure. Everybody okay with a, ooh, got fractions here. 9/2, comma 1, is that right? Let's talk about just a little bit here. Again, improper fractions is usually the way they want to answer it. The only problem is when we're going to be graphing this, we probably want to change it to a mixed number, right? Because you want to know, okay, which two numbers are in between. Yeah, so this would be about 4.5 or 4.5. At that point, now you can graph it. So there's going to be, as an answer, you probably want to write this one. As you graph it in your mind, at least change it to a mixed number. See what numbers are in between. All right, and then plug it in -1 for the x, or plug it in at -2 for the y. Let me just give you the answers here. See if you guys agree. For this one, I got a -8/3. So it'd be -1, comma -8/3. For the next one, slightly of a tricky thing here. -3 times -2 is a +6. So whenever you take the 6 to the other side, you're going to subtract 6 from both sides, and you get yourself a 0. And that's okay, because you still have an x that you're solving for. So divide both sides by 2. 0 divided by 2 is still a 0, so the answer is actually x equals 0. Let's see, the negative 2 came in for the y, so the x is 0, so the x has to go first, so 0, comma, negative 2 is the final coordinate there. All right, let's talk about this here. Let's see. So in this case,
When you multiply -3 and -2, isn't the minus sign still the same?
no, because it's going to be really a negative times a negative is a positive. So it just changes. So there's one little easier trick which we'll work with quite a bit here is whenever you have an equation that's already been solved for y, such as number 3 here. So it says y is equal to 4x minus 8. And you should notice that this is a lot easier to plug in, especially for the first two, because you're not doing any algebra at all. Actually, you're just doing pre-algebra here. You can probably even plug that into your mind, is that right? If you plug in a 0 for here, 0 times 4, minus 8. That's a lot easier, huh? If I have something solved for y, a lot easier to work with. The other two, not so difficult, because now I've got to plug in a 0 and the 4 for the y value, then I got to do some algebra. But the first two, awesome, I like that. I didn't even need to do any algebra whatsoever. Plug in 0 in for the x value, that goes away. The answer is negative 8 to do whatsoever. There's my answer right away. Totally like that one. Since it's solved for y, plug in a 1, and again, still no algebra to do, because 4 times 1 is 4, 4 subtract 8 is a negative 4. I like that as well. On the other two, yes, there's some algebra to do, because we're not plugging in stuff that's been solved for. 0 goes in for the y value, and I got to do some algebra. Still somewhat pretty easy though, right? Add 8 to both sides. 8 is equal to 4 times x, divide by 4, and we get ourselves x equals 2. So how about 2 comma 0? And most of you guys are done here, so plug in a 4 for the y value. I heard 3 is the answer, I think so as well, because if you add 8 to both sides, you get a 12. 12 is equal to 4 times x, divided by 4. On both sides, you get x equals 3. I think an x always has to go first, followed by the y at the end. All right, so these are all three our solutions, right? Negative, or 1, negative 4 is a solution, because if I were to plug in 1 for the x, I get a negative y for the 4. Sorry, negative 4 for the y. So let's do this here. One more thing here. Let's verify. Verify if certain things are solutions. Just like chapter 2, I think we did that before. To verify if something is a solution, all we had to do is plug it in and make sure both sides equal each other, right? Because that's what a solution means. So, can you plug in 5,3, and I want to know whether 5,3 is a solution to this equation called 3y is equal to 5x plus 15. right, those of you working ahead of me here, what do you guys say? 5-3, is that a solution, yes or no? Okay, I heard a no for this one. So we're going to plug in again. It's xy, so the 3 goes in for the y, 5 goes in for the x. Verifying that. I don't think so. 3 times 3 is 9. 2 times 3 is 20. Oh, sorry, 5 times 5 is 25. Plus 15 make 40, and I don't think so. 3, 0. Try this one here. Again, just plug it in 0 in for the y value. The 3 goes in for the x value. Adding things up gives you a 0 is equal to 15 plus 15, or 0 is equal to 30. I don't think so. All right, last one here. Let's see. 3, the 5/3 goes in for the y value. The -2 goes in for the x value. And the 3 is because you have a whole number multiplying a fraction. Remember what we do is we just make both of them fractions. Cancel both of those. It leaves you with a 5 on the left-hand side. 5 times -2 is -10. -10 plus 15 then would give you a 5. Perfect. So we verified that out of those 3, -2 comma 5/3 is a solution. But how many solutions does 3y equals 5x plus 15 have? Yeah, there's an infinite amount of solutions, right? We just found one of them. All right.